This is problem number 3 from section 7-5. It says, use the given confidence level and sample data to find the confidence interval for the population standard deviation sigma. Assume that a simple random sample has been selected from a population that is normally distributed. This data is based on salary of college graduates who took a geology course in college. We want an 80% confidence level. The n is 91. We have the mean at 60,200 and a standard deviation of 16,942. So for us to do this, it would be good to know the formula for the standard deviation. Unfortunately, there's no quick calculator way of doing this unless you have a special program installed or written in your into your calculator. And for that, you can go to Learning Center and see Frank Austin or Nancy Ward. But this tutorial will show you how to do it just using the formula and the calculator without that special command. So let's take a look at that formula. If we go to the ebook and scroll all the way down and take a look at the formulas and tables fold-out card, we see immediately over here a formula for the confidence interval, one population for the variance. And so it's not the standard deviation, but there's an intimate relationship between the variance and the standard deviation, and that from the variance, if you want the standard deviation, you just take the square root. So we'll keep that in mind, that our standard deviation formula will be the square root of whatever this expression is that we get from the variance. The other thing that we need are the critical values. So for that, we again go back to your formula card, and this time go all the way down to table A4, where we see the chi-square distribution. And so with this chi-square distribution, what we're going to do is we're going to recall that we are looking for an 80% confidence, and remember that our n is equal to 91. So from there, our degrees of freedom is 90. And if we look at our chi-square distribution, we want the area in the middle to be 80%. So that means the area of each of these tails will be 10%. But remember, this table is looking at the area to the right of the critical point. So this right-hand side, the chi-square r, is okay, but the chi-square L, we have to consider the complement of 10%, which is 90%. And that'll help us find the chi-square L. It just happens that those two values would be towards the middle of the table, and all we need to do is look at our degrees of freedom to be 90. That's pretty close to the bottom over here, and we see these two values as our critical values that we're looking for. So let's take that piece of information, go back to our scratch work, and remember that these would be our critical values, and let's label them appropriately. This is your chi-square L and your chi-square R. Just keep in mind that in the actual formula, chi-square R is on the left side of the inequality and the chi-square L is on the right side of the inequality. So remember that. Okay, now we take our calculators out. Let's clear everything out so that we don't get messed up with any other pieces of information. And then let's start punching in the values. So first of all, we remember that the square root, so let's see if we can do this with our calculators. So square root is the second function of x squared. And then we have n minus 1. Now you can probably subtract 91 minus 1 yourselves, but I'm going to write this out anyways according to the formula. And then multiplying times the standard deviation, that's 16,942. And then we square it. And then from here we divide by chi square r. So remember, it's chi square r. That's 107.565. Okay, that should be it. This is all under square root. Press enter. And then we got 15,497.1. I guess we want to round to the nearest dollar. So we'll just say 15,497. Now we're going to do the exact same calculation, except for the denominator is going to change from 107,565 to 73.291. So instead of retyping everything over, I'm going to press a second and enter buttons. And then what I'm going to do is I'm going to generate the same entry that I had before. And if I just move the cursor to the left and just overwrite this with 73.291, notice I have that 5 still blinking over there, so I don't want to press clear, because clear is going to clear the whole line. I'm just going to press delete, and that will get rid of that last digit. Now I'll press enter, and then I'll get my value. Let's just take a screenshot of this and paste it onto our notes so that we can see clearly. If you were doing this in a test situation, of course you're not going to enter the data, you're going to write this by hand, and to write this by hand, you'll write the left hand side, that's 15,497 less than sigma less than 18,774. Okay? But if you're going to input this in the computer, the output was 15,497 and 18,774. So that looks like it worked out well for us, and we got the right answer.